Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine the direction of a vector. So when we're looking at determining the direction of a vector, basically there's a couple things we need to do. Obviously, we have a formula that we can relate to using triangles, but also we want to just kind of use some common sense as far as sketching the vector and to kind of understand where the vector is and to make sure when we're using our calculator, we're not determining the reference angle, which I'll talk to you about in a second. So first of all, whenever when we're trying to find the angle, specifically using right triangles, we're going to want to use trigonometry, basically looking at using sine or cosine and tangent. So we have an angle theta, and we obviously know that a vector composed of, especially when we're looking at linear combination, is composed of i's and j's. So if we want to be able to find the angle, we're going to want to use the tangent function. So if we're given a vector, let's just call that vector v, where that vector is v1 comma v2. The tangent of an angle is the j over the I, or we could say the tangent of an angle theta is v2 over v1, if you're looking at it in component form. Or you could obviously say, you could also look at it as the coefficient of your j over the coefficient of your I. But it's really, really important to recognize that the relationship of finding the angle of a vector is similar just to that of creating a triangle, which again I'll kind of show, and as well as just sketching the angle. So let's go ahead and take a look. First thing I like to do for all of these problems, especially when I'm understanding this, is sketch the angle. And so a vector, here we have 2, comma 2. So I go 1, 2, up 2. So I go over 2, up 2. So there's my vector. Right? So if I wanted to find the angle, then basically I can just kind of create a little triangle here. Nice little right triangle, and say that's the angle I basically want to find. I want to find the angle with the x-axis from our standard form. That's the angle we're going to be determining. So we know that this length is 2, and we know this length is 2. So you could also say that that's v1 and that's v2. So the tangent of my angle theta is equal to 2 over 2, or tangent of an angle theta is equal to 1. Now again, to remember to determine what the angle is, so if we have tangent of an angle is equal to 1, to solve for tangent, we need to use the inverse tan on both sides. So I'll take the inverse tangent on both sides. Therefore, I'm left with theta equals tangent inverse of 1. So now I need to go to use my calculator, or if you're familiar with your unit circle, you could probably go ahead and determine this answer here right now. But I'm just going to use my calculator because that's what we're going to be using for the rest of these, just to kind of show you. I will relate it, though, however, also to the unit circle. So make sure, though, for your calculator for these problems that we're working in degree mode. Actually, I think I just clicked on it. Yeah, you want to make sure you're in degree mode. So therefore, I just hit second tangent, which gives me the tangent inverse of 1. And I can see I'm left with 45 degrees. Tangent theta equals 45 degrees. And you can see here, if that's 2 and that's 1, oops, that creates my nice little unit circle. And the tangent of 1 is square root of 2 over 2, comma square root of 2 over 2, right? So you can see those two angles. That's how it relates to the unit circle. And that exactly, and answer positive 45 degrees, that looks like it checks out. OK, let's go down the list here. So if I was just going to follow my formula, v1, v2, I would just have tangent of theta equals negative v2 over 0 comma negative 2, which is 0, negative 2, 3i. OK. Negative 2 over 0, which is undefined. So tangent of theta equals undefined. Now, you might be a little bit confused. Well, how are we going to find the angle then when tangent is undefined? Well, there's a couple ways. First of all, why don't we just sketch the vector? If here's my starting point and I'm going down to negative 2, now all we need to do is identify what is the angle from our standard position over to here. Well, we know all the way around a circle is 360. Half of a circle is 180. Half of that is 90. So 90, 180, 270. I can also confirm this by looking at the unit circle. We know that the unit circle, right over here, this point is 0 comma negative 1, where tangent, which is the y coordinate over the x coordinate, is also undefined. So we see that tangent is undefined here as well as here, but as well at 0, negative 1 and at 0, comma 1. But we know by graphing the vector that the angle has to be 270 degrees. All right, lastly, let's go and look at, I'm sorry, that's not right. 4, -2, that's supposed to be a positive 4, -2. Okay, so let's go and look at this last example. Again, let's sketch it first. So I'll go over 4, 1, 2, 3, 4, -2. Okay, so it looks something like that, right? So if I apply my formula, tangent of theta equals V2 over V1, even though I guess since we're changing the vectors here, this is really W1 divided by W2. This is really X1 over X2. So therefore, I have -2 over 4, which equals -1/2. So therefore, theta equals tangent inverse of -1/2. Now, when I go to my calculator and I plug this in, so I do second tangent of -0.5, and I get -26.56 degrees. Well, that is correct. -26.5 degrees is right here. But if we want to go ahead and write this as a positive angle, basically what we need to do is we need to find this angle from right here. So what I'm going to do is that's going to be approximate 57, I'll do this, equals -26.57. So to find my angle as positive, I'm going to do theta equals 360 degrees, which is the distance all the way around the circle, minus approximately this reference angle, which is 26.57. Notice that I'm using it as a reference angle. I'm looking for all the way around a circle minus this chunk. So that's why I'm not minusing a negative, because that would be the same as like adding. So my angle would be greater than 360. I'm just looking for the measurement minus that little chunk. So when I do 360 minus, plus the second answer. Dang it. Okay. 360 minus 26.57. And now I get approximately theta is approximately 33.43 degrees. Okay? And that makes more 333.43 degrees. Okay? So now let's go and take a look at another example. Here I have an angle that's at -6, 2. So at -6, I'm going to go 1, 2, 3, 4, 5, 6. Well, 2. Let's go right there. All right? So to evaluate, let's say that's V1, that's V2. So, or you could rewrite it like this, -6, 2, V1, V2, right? Identify your components. So when I do the tangent of theta equals 2 over -6, I have theta equals tangent inverse of -1/3. So again, now we're going to do, use my calculator. So I do inverse tangent of negative, and I'm not going to use a decimal this time. 1 divided by 3. I'm going to use a fraction. And I get -18.43 degrees. Well, there's an issue because my vector is over here, right? So I know -18.3, but what that is that's the reference angle. They're again giving you this angle right here, -18.43 degrees. Well, yes, that's the angle, but that is this angle using vertical angles are exactly the same. But that's not the angle that we're looking for. We're looking for the positive angle, which is from here to here. So again, if all the way around this circle is 360 and I subtracted this chunk, here, this chunk right over here is -18.3. Halfway around the circle is 180. So I'm going to take 180 degrees and minus it from the reference angle, meaning that this value we're going to treat as positive. So I'm going to do 180 degrees minus 18.43, which is my approximation. And I get theta equals 161.57 degrees. And does that make about sense? Yeah, that's between 90 and 360, so that works. Let's go and work on the last two here. So this one, I'll just kind of speed this along. So I can have tangent of theta is equal to -2 over -1, which is equal to +2. So therefore, I can say theta equals tangent inverse of 2. Again, we should graph this. So that's -1, -2. Okay, so I do second tangent of 2, +2, sorry, and I get 63.43 degrees. Crap. Well, again, what we need to look at is what did they give us? They gave us the reference angle. They're giving us 63.43 degrees, which is right here, which is the same as that angle. These are vertical angles, so they're exactly the same, but that's not the angle we're looking for. We're looking for this angle from here to here. Well, if you notice this straight line here, that's created a, I created a straight angle, which would be a straight angle. So basically, I'm taking this angle and then adding it to a straight angle, and a straight angle has a measurement of 180 degrees. So then all I need to do in this case, when when my calculator gave me the reference angle, is I just need to now add 180. So therefore, I'm just going to take my second answer and just add 180, and I get theta equals 243.43 degrees. Okay? Last but not least, I'm just going to do this one. I'm not going to use my calculator because I don't need to. Here's my vector as a linear combination. In component form, it looks like this, 3, 0. If I was going to go ahead and graph that, I would get 1, 2, 3. Okay? And therefore, I know that the angle of theta in this case is just going to be 0 degrees. Please note, if y equaled negative 3i, then my vector would be over here, and it wouldn't be 0 degrees, but it would be theta equals pi, or I'm sorry, 180 degrees. Right? And that's actually what I meant to do. So y equals 3i, theta equals 0 degrees, but if it was y equals negative 3i, then my angle is right there, so therefore theta would equal 180 degrees. So very close, just to make sure you know the difference. So finding the angle is a pretty simple formula. Tangent of theta equals the second component over the first component. However, you got to be careful when using your calculator. Your calculator is going to often give you the reference angle or the positive value, so you need to be able to understand where that vector is or lies on the contract, on the quadrants. So therefore, you can identify using reference angle to find the exact value. Thanks.